In this video, I'm going to review the solutions to the examples 1 through 4 that you were asked to do in the 9.3 reading summary so that you can check your understanding. So the first problem you were given as an example out of 9.3 is that you were asked to consider the 12 months to be a modulo 12 system, with December being month 0, January is month 1, February is month 2, and etc. And that's actually a different setup than what the textbook had you do, because they wanted them all to be one off, basically. But I think, you can make your own systems, starting places, where they make the most sense. And since this would give me 11 of the 12 months that would have the number that we're used to associating with them when we make dates, that's why I went with this. So the only sell-off I had to do is make December a 0 instead of a 12. So, if it is currently October, determine the month it will be after the times given in this exercise have passed. So again, as a reminder, 0 is December, 1 is January, 2 is February, so forth and so on. And we're starting in October. So we're starting with 10. Each one of these cases. So 61 months from now, I'm going to take 61 months and add it to 10 and get 71. And when I do 71 divided by 12, I get 5 with a remainder of 11. Well, this remainder is what I'm mainly looking for, and that coincides with November. So that means that 5 full years went by, and that remainder of 11 just means, okay, well, I'd be on the 11th month at that point. So not too difficult. Next one. 4 years, 8 months from now. Now, the years I can pretty much ignore, because if I say, okay, I'm in October, and 4 years from now, I'm going to be back to October, because I'm still, I've done 4 full cycles. It's really the 8 months I'm concerned with. I'm going to add that 8 months on to 10 and get 18, divide that by 12, I would get another additional year. The year would change over with a remainder of 6, which means that coincides to it being June. 7 years from now is kind of a no-brainer, because it's seven full years from now. So if I'm in October, 7 full years from now, I expect to also be in October. And likewise, 5 years, 9 months. Again, I ignore the 5-year part, because that'll be 5 full cycles getting me back to October again. I'm going to add this to the 10 and get 19. Dividing by 12 gives me a 1 with a remainder of 7. And of course, that remainder of 7 tells me that we would be in July. For the next set of problems, you're given these additions, subtractions, and multiplications to do, and you're asked to come up with an answer in this case, all modulo 8. So when you do this, all you're really going to be doing is just adding the numbers together, or doing whatever they ask you to do, and then adjusting that number. If it's a number that's less than 8, I just leave it alone. If it's a number that's over 8, or if I start getting into negative territory, I have to make some adjustments. So for instance, 5 plus 6 is 11. That 11 would not be a number written in modulo 8. In modulo 8, there's only 8 numbers, 0 through 7. So I got to find out what would relate to 11 here. So I would take 11 divided by 8 and get 1 with a remainder of 3. And that remainder of 3 is what this would be congruent to in modulo 8. So this is not an equal sign, it's a congruent to sign for modular arithmetic. 12 minus 3 equals blank modulo 8. So again, I'm going to do 12 minus 3 and get 9. 9 divided by 8 gives me a 1 with a remainder of 1. That remainder of 1 is what goes here. And so 12 minus 3 is congruent to 1 modulo 8. 4 times 6 is 24. 24 divided by 8 gives me 3 with a remainder of 0. So this would be related to 0 modulo 8. 3 times 5 is 15. Divided by 8, I get 1 with a remainder of 7. And so that 7 is what goes here. So 3 times 5 is congruent to 7 modulo 8. And then 3 minus 6. If I do 3 minus 6, I get a negative 3. Now this is a little bit different, because I don't want to just go into dividing them by 8, because these numbers in the modulo system should always be positive, even though the subtraction would indicate normally a negative number. So I got to figure out what's equivalent to 3 to the left of 0 in a modulo 8 system. So I could either write that out a bit, or basically, if I get a number that's less than the modulus number, I'm just going to add 8 to it. And that gives me a 5. That means if I do a full cycle of 8 away from -3, I would be at 5. And so 5 would be in the same general location in the cycle as -3 would have been. So that's what I ended up putting here. Now for these, I wanted you to, in these cases, put in the number that's on the left-hand side, so you have to know what to add or subtract to this. And basically, the reason why you're basically told that it has to be less than the modulus that correctly completes each statement is because theoretically there's an infinite number of numbers I could put over here. Say the number, I don't know, 3 works in this thing here. Then 8 would also work. Then 13 would also work. Then 18 would also work, and so forth and so on. It would all do the same thing because you're moving in the same cycle, in modulus, whatever you're talking about here. So we're looking for the smallest possible value, and if there's more than one that's less than the modulus, then I'd look for that too. So the way I look at this problem is I have blank plus 3 equaling 1 times 5 plus 2. So that means I'm going to have, I'm assuming I have at least, it's not just 2 itself. Although I could probably say, okay, well, 2 by itself modulus, so I'm just going to move 5 away from that, and that would give me the next one in line. That would make sense. So, but in this case here, that would give me a 7. So I'm looking for a blank plus 3 to equal 7. And that would give me 4 plus 3. For the next one, 4 plus what equals, is congruent to 3 modulus 6. So I got to think of this number over here as essentially being 1 times the modulus plus the remainder of 3. So that would give me 9. So 9, when I divide it by 6, would give me a remainder of 3. So that's like the smallest non-zero, it's the smallest positive value that I could get that would give me a remainder of 3. So I now know that 4 plus whatever this is has to total 9, and I know that 4 plus 5 totals 9. Now for this next one, I had to do a little bit more thinking here, because I want to do 3 minus something is congruent to 7 modulo 9. Now, usually when I do a subtraction problem, I end up with a number on this side that is smaller than the number on this side, especially when I'm only considering positive digits here. I'm only considering in mod 9 the digits 0 through 8. So right now, the way it stands, I'd be a little bit more hard pressed to try to figure out, well, what's congruent to 7 modulo 9. It would be the result of me taking something away from 3. So I expect the number, I expect, this value over here to be something that overall is going to be less than 3, but it still is congruent to 7 modulus 9. So what I got to determine first is what that's going to be. So I'm going to take this 7, and I'm going to subtract away the modulus number to get the next number in the sequence that would technically, in regular base 10 numbers, would be the same congruent-wise as 7 in mod 9. So negative 2 would be congruent to 7 in modulus 9, theoretically. So I'm looking for a value now that where 3 minus that number would give me negative 2. So this is much more feasible, because now you say, okay, well, I'm going to lose that 3 plus 2 more, so I got to be taking 5 away. So 5 would be the number I put here. When I deal with multiplication problems, it's a little bit of a different situation, because what I need to do is more or less figure out, there might be more than one number that could possibly fill the bill, which, sometimes could happen, sometimes can't happen. So when I look at 3 mod 7, well, there's a number of other numbers that would be congruent to 3 in a modulus 7. And so some of those numbers, starting with 3, would be, 10, 17, 24, 31, 38, 41. As you can see, all I'm doing is jumping up by 7 each time on this list. And, if I keep going, I'd have 48, so forth and so on. And as a matter of fact, I might even want to include that for this discussion right here. So let me put that at the end here. I'll just put it in 48, and go from there. So now when I look at this though, I say, okay, well, all of these would be congruent to 3 in a modulus 7 system. Which ones of these, integers would come about by me doing 4 times something? Well, as you can see, 3 is not divisible by 4, 10 is not divisible by 4, 17 is not divisible by 4, 24 is. So 24 is divisible by 4, and technically, if I go further, 48 would also be divisible by 4 as well. So, so now I have to think, okay, well, what would, I do to get 4 times what would give me these two numbers? So 4 times what would give me 24 in this case? Well, that would be a 6. 4 times 6 is 24. To get to 48, I would have to multiply 3 by 16, which is certainly over the modulus number. So that's why, even though 16 would be another correct answer, they did ask us to get one that's less than the modulus number. So that's why I'm not including the 48 there. Because, technically, all of these would have an infinite number of answers along with it. So for the next one, 3 times blank is congruent to 5 mod 6. So again, I'm going to make a list of numbers that are congruent to 5 in modulus 6. So 5, 11, 17, 23, 29, 35, 41, 47, 53, 59, and 65. All of these, are a result of that. So as I look through this list of numbers, none of these numbers are divisible by 3. I can keep this list going, no matter how much I make that list keep going. But no matter how much I extend this list, there is no number that's going to be divisible by 3. So 3 times some integer is never going to be congruent to 5 modulus 6. And so based on the direction, that's why I put that n there. And then lastly, blank minus 3 is congruent to 4 modulus 8. Now here, I'm expecting a number bigger than 4 here. And so I got to think, okay, well, what minus 3 is going to be basically equal to 4, and is going to be a number that could be less than 8. Well, from basic arithmetic, 7 minus 3 does equal 4, and therefore, since that is less than the modulus number, that would work, and therefore that would be a suitable answer for this. For this last problem, you're told that a pilot is scheduled to fly for 5 consecutive days and rest for 3 consecutive days. If today is the second day of her rest shift, choose all of the situations below during which the pilot was or will be flying. So, based on the information we have in the problem, her schedule kind of looks like this. Where F stands for flying, R stands for rest. And we're told that she's currently on her second day of rest. And so that's where we're starting this cycle from. We want to see, okay, which one of these are going to be situations where she's going to be flying at the time mentioned. So if it says 90 days from today. So now when I look at this, obviously, this is basically a modulus 8 system here. And so what I'm going to do is assign these values to numbers in a modulus 8 system, 0 through 7. And so when I come up with a number for what is congruent to in modulus, that would correspond with one of these letters. So if I take this being day 6, and depending on how you chose to set it up, by the way, you can have a different number here, but it would still work out the same way. They would still correspond to the right F's and R's based off of the fact that if you followed this description correctly. So if I take 6 and add 90 to it, I get 96, which I would divide by 8, which would give me 12 with a remainder of 0. Now that remainder of 0 is what tells me that it's going to correspond to this 0 down here, which is a flying day. So she will be flying at that time. In the next instance, 20 days ago, so I'm going to start with that starting day of 6. And I'm going to subtract 20 from it, giving me a negative 14. Now it's a negative number. I need to at least get a positive number. So I'm going to be taking this negative 14, I add 8 to it to get a negative 6, which is still negative. And I add another 8 because that's the modulus number that gets me to 2. So that's the first the first positive number that I get, modulus 8. And so this would equate to being congruent to 2 modulus 8, and therefore this 2 tells me that on this, because it corresponds with the flying day down here, would be another day that this pilot is flying. Now 6 days ago, starting at 6 again, the day 6 of her cycle, subtracting 6 would give me 0, and 0 of course corresponds down here to this 0 here, which would be another flying day. 60 days from today, I would take 6 plus 60, you get 66. Now 66 divided by 8 would give me an 8 with a remainder of 2. So basically, you know, if 60 days go by, I've done 8 full cycles of these plus 2 more additional days. So I would get the 8 full cycles give me at 6. The 2 more would give me at 7. Or basically get you to this part right here, where I'm corresponding to another flying day. So it would be another flying day. And 240 days from today, so I would do the same thing. I have 240. 246 divided by 8 is 30, with a remainder of 6, which means I go through 30 full cycles of this, and then I have 6 more days remaining, which puts me right here, back to the same place again at a resting day. So this resting day is the only one I have on this list, and your list might be in a different order because it was set to be randomized. So, but that's the only that's the only description that's given here that she would be resting. The other day she would be flying.
And that is the end of this video. If you have any further questions, please make sure to reach out and ask me about it. Until next time, have a good day.